Hello, everyone! Have you ever wondered how doctors can measure incredibly tiny amounts of hormones in your blood? Sometimes the concentration is so low that ordinary laboratory methods simply can't detect it. This is where radioimmunoassay, or RIA, changed medical science forever. RIA was the first laboratory technique capable of detecting substances present in extremely small quantities, allowing scientists to accurately measure hormones, drugs, and many disease biomarkers. Today, let's explore how this revolutionary technique works. Radioimmunoassay, or RIA, was developed in the late 1950s by Solomon Bersin and Rosalind Yellow. The technique was originally designed to measure insulin concentrations in human serum. Their groundbreaking work revolutionized laboratory medicine by combining two powerful principles: the exceptional specificity of antibodies and the high sensitivity of radioactive detection. This innovation enabled the accurate measurement of extremely small amounts of hormones and other biological substances in blood and other body fluids. In recognition of this pioneering achievement, Rosalind Yellow was awarded the Nobel Prize in Physiology or Medicine in 1977. To understand RIA, we first need to know its three essential components. First is the antibody. Think of the antibody as a highly specific lock that recognizes only one particular molecule. Second is the radioactive antigen, also called the labeled antigen. This antigen is chemically identical to the patient's antigen, except that it carries a radioactive isotope, allowing scientists to detect it. Finally, we have the patient sample, which contains the unknown amount of unlabeled antigen that we want to measure. The goal of the assay is to determine how much of this unlabeled antigen is present. The key principle behind radioimmunoassay is competitive binding. Imagine there are only a limited number of antibody binding sites. Now, two types of antigens compete for those binding sites. One is the radioactive labeled antigen. The other is the patient's unlabeled antigen. Because both molecules have the same structure, the antibody cannot distinguish between them. They compete equally for antibody binding. If the patient's sample contains only a small amount of antigen, most antibody binding sites will be occupied by radioactive antigen. As a result, the measured radioactivity will be high. However, if the patient's sample contains a large amount of antigen, the patient's antigen outcompetes the radioactive antigen. Fewer radioactive molecules remain bound to the antibodies. Consequently, the measured radioactivity decreases. This is why RIA has an inverse relationship between radioactivity and antigen concentration. In simple words, more patient antigen means less radioactivity detected. Remembering this single concept makes RIA much easier to understand. Now let's look at the laboratory procedure. First, the labeled antigen, patient sample, and a known amount of antibody are mixed together. Next, the mixture is incubated to allow competitive binding to reach equilibrium. After incubation, the antibody-bound antigen must be separated from the free antigen. This separation step is essential because only the bound fraction will be measured. Finally, the radioactivity of the bound complex is measured using a radiation detector. The measured radiation is then compared with a standard calibration curve to determine the concentration of antigen in the patient's sample. Radioimmunoassay, or RIA, has played a major role in clinical diagnostics. It is commonly used to measure hormones such as insulin, thyroid hormones, cortisol, and reproductive hormones. RIA can also detect therapeutic drugs, vitamins, tumor markers, and viral antigens. Because of its extremely high sensitivity, RIA became one of the most important diagnostic tools before newer immunoassays were developed. Radioimmunoassay, or RIA, and enzyme-linked immunosorbent assay, or ELISA, are both highly specific analytical tools used in clinical laboratories to detect and measure the concentration of antigens or antibodies in a sample. While they share the common goal of using immunological reactions for detection, they differ primarily in the labels they use for measurement. RIA uses radioactive isotopes, while ELISA uses enzymes. Although RIA revolutionized laboratory medicine, it has largely been replaced by ELISA. Unlike RIA, ELISA uses enzymes instead of radioactive isotopes. This eliminates radiation hazards and reduces disposal costs. ELISA is also easier to perform in routine clinical laboratories and is much safer for laboratory personnel. However, RIA remains one of the most sensitive immunoassays ever developed and is still used in certain specialized laboratories where maximum sensitivity is required. Let's summarize. Radioimmunoassay is a highly sensitive laboratory technique used to measure tiny amounts of biological molecules. It works by competitive binding between radioactive labeled antigen and patient antigen. The higher the concentration of patient antigen, the lower the measured radioactivity. Although ELISA has replaced RIA in many laboratories, RIA laid the foundation for modern immunodiagnostics and remains an important milestone in laboratory medicine. All right, let's see how well you were paying attention. Here is your pop quiz. What is the fundamental principle of radioimmunoassay? Is it A, DNA amplification, B, competitive binding, or C, enzyme digestion? The correct answer is B, competitive binding. RIA based on competitive binding between a known amount of antigens labeled with a radioactive isotope, such as I-131, and the unknown unlabeled antigens from the patient sample for a limited number of antibody binding sites. Question 2. If the patient's sample contains a high concentration of antigen, what happens to the measured radioactivity? A, it increases, B, it remains unchanged, or C, it decreases. The answer is C, it decreases, because more patient antigen competes with the radioactive antigen for antibody binding. Final question. Why has ELISA largely replaced radioimmunoassay in clinical laboratories? A, ELISA is more radioactive. B, ELISA uses enzymes instead of radioactive isotopes, making it safer. Or C, ELISA does not require antibodies. The answer is B. ELISA uses enzymes instead of radioactive isotopes, making it safer. How many did you get correct? Let me know your score in the comments below. If you enjoyed this video and found it helpful, don't forget to like, subscribe, and share it with others interested in molecular biology. Thanks for watching. Stay curious, keep exploring, and we'll see you in the next deep dive into the wonders of science.